Displacement reactions. Single displacement reaction is a chemical reaction in which one element takes the place of another element in a compound. If you look at the activity series, it provides a list of elements organized according to their chemical reactivity. The most reactive element appears at the top, and the least reactive element appears at the bottom. Double displacement reaction, then, is a chemical reaction in which the positive ions of two different compounds exchange places, resulting in the formation of two new compounds, one of which may be a precipitant. In a single displacement reaction, a reactive element, a metal or a nonmetal, and a compound react to produce another element and another compound. Therefore, it's a chemical reaction in which an element takes the place of or displaces another element in a compound. Single displacement reactions can be represented by general chemical equations and pictorial as given. The first equation from the previous slide shows a reaction involving a metal or replacing another metal. The second equation represents a reaction involving a nonmetal replacing another nonmetal. Think about placing aluminum foil into an aqueous solution of copper 2 chloride. The reaction that will occur is a single displacement reaction, which can be represented by this chemical equation. 2 aluminum plus 3 CuCl produces 2 AlCl plus 3 Cu. This action equation shows how the metals colored blue behave. Shown in the diagram, the aluminum displaces the copper to form an aqueous solution of aluminum chloride and a copper precipitant. The reaction in the picture shown on the left displays the result of placing a piece of copper wire into an aqueous solution of silver nitrate. Metallic silver forms on the surface of the wire. The solution turns blue because copper atoms from the wire turn into ions and dissolve into the solution. The copper displaces the silver from the compound silver nitrate in the solution. The balanced chemical equation for the reaction is Cu plus 2AgNO3 produces CuNO3 plus 2Ag. Notice that copper, a metal displaced by silver, also a metal, during the reaction. Because the metal forms positive ions, it must displace the positive ions from the compound so that a new ionic compound can be formed. You might be wondering why the reaction described in the previous slide does not go in reverse. Why does silver not simply displace the copper? The answer lies in the reactivity of metals. You may recall from your study of the periodic table that alkali metals, which is the name for the elements in group 1, are described as the most reactive metals. So not all metals are equally reactive. By trying many combinations of metals and compounds, scientists organized the metals based on their reactivity in an activity series. An activity series is a list of elements organized by their chemical reactivity. The most reactive element is at the top of the list, and the least reactive element is at the bottom. This photo shows the activity series for the metals. Reactive metals displayed or replace the metals in a compound that is below it in the activity series. As you can see from this picture, copper appears above silver, so copper can displace silver, but silver cannot displace copper. If you place a piece of silver into an aqueous solution of copper, no reaction will occur. Notice that there is one element on the activity series of metals that is not a metal, and this element is hydrogen. Because hydrogen ions can be positively charged, metals can take the place of hydrogen compounds. The element formed in the single displacement reaction is hydrogen gas. In the photo shown here, you can see the result of placing a piece of zinc metal into hydrochloric acid. You will learn more about acids in the course. The balanced chemical equation for this reaction is zinc, Zn plus 2HCl produces ZnCl2 plus H2. Keep in mind that metals above hydrogen in the activity series can replace hydrogen from an acid, but that the metals below hydrogen cannot. Pause the video, read this sample problem, and try the practice problems. Then join me to continue. Replacing nonmetals with metals. The ion of a nonmetal, such as a chloride ion, is negatively charged, so it can be replaced only with another nonmetal. For example, in the reaction between chlorine and sodium iodide, fluorine replaces the iodine to produce iodine and sodium chloride. The balanced chemical equation for the reaction is F2 plus 2NaI produces I2 plus 2NaF. This is a separate activity series for nonmetals. You can determine this activity yourself by doing the activity 5.3 given on the next slide. The activity series for nonmetals works in the same way as the activity series for metals, with the most reactive element at the top of the list. Did you get it? Now, I want you to complete this activity. Pause your video and join me when you're done. Double displacement reactions. A double displacement reaction is a chemical reaction in which the positive ions of two compounds change places in the solutions to form two new compounds. The reactants of a double displacement reaction are often aqueous solutions of ionic compounds. For the purpose of this chapter, you will be studying the double displacement reactions of the obvious solutions that result in a precipitant as one of the products. Double displacement reactions can be represented by a generally chemical equation or pictorial given below. So AB plus CD produces AD plus CB. In the equation from the previous slide, A and C are cations and B and E are anions. For example, as shown in this picture, when a yellow aqueous solution of potassium chromate, K2CrO4 aqueous, is added to a colorless aqueous solution of silver nitrate, AgNO3, a red precipitant, Ag2CrO4 is formed. In a later science course, grade 11, you will learn how to determine which product forms precipitants and which combine do not react. Pause the video. Here's another sample problem and practice problems. Chemical reactions and food preservatives. Sulfur dioxide has traditionally been used to preserve the light color of certain dried fruits, such as dried apples, golden raisins, and dried apricots. Sulfur dioxide gas is produced from an initial double displacement reaction. The balanced chemical reaction is given. Na2SO3 plus HCl, of which we have 2 molecules, produces 2 molecules of NaCl plus H2SO3, and the second, H2SO3, produces H2O plus SO2. So, for dioxide gas is absorbed into the skin of the fruit. Without the sulfur dioxide, the fruit would darken and change flavor as it dried. When a package of dried fruit is first opened, residual sulfur dioxide gas and the smell of sulfur may be noticeable. Some individuals are allergic to sulfites. This has prompted many companies that produce dried fruit to place a cautionary statement on their packaging to alert people about the presence of these agents in food. This table summarizes the 4 types of chemical reactions. I would suggest that you have this available to you as you complete this lesson. These characteristics will help you identify each type of reaction and determine their products most likely to form. Please submit all of the work assigned in this lesson, 4 practice problems and activity 5.3 to the types of chemical reactions assignment box.